Hello, I'm Jenny Lynch, and this is the Creative Science Podcast.
Hi, I'm Matilda, and today's show is all about icy science and the states of matter.
Get ready for some super cool science with fascinating frosty facts about ice, a deep dive into the Earth's coldest places, a question about how fish survive swimming in sub-zero seas, some history of refrigeration, and a salty ice experiment for you to try yourself at home. Rug up against the cold because here come 5 fun and frosty fast facts about ice.
Fact number 1. When liquid water freezes, it turns into solid ice.
The freezing point of water is 0 degrees Celsius, and the freezing point of water is the same temperature as the melting point of water. If liquid water is cooled below 0 degrees Celsius, it will freeze to make solid ice. If ice is heated above 0 degrees Celsius, it will melt to make liquid water.
Fact number 2. Changing from a liquid to a solid, or a solid to a liquid, is called a change of state.
There are 3 states of matter that we see in our day-to-day lives: solid, liquid, and gas. The 4th state of matter is called plasma, and it forms when a gas gets really hot. If you've ever seen a flash of lightning, then you've seen light from the glowing gases in a plasma.
Fact number 3. When water freezes to make ice, the solid ice is bigger than the liquid water.
When water freezes, the water molecules stick to each other in a regular pattern to form ice crystals. The crystal structure takes up more space than water molecules in the liquid state. This makes water a bit wacky compared to how most chemicals behave. When most chemicals freeze, they take up a smaller space.
Fact number 4. Ice takes up a bigger volume than liquid water, so ice has a lower density than water.
Density is a measure of the amount of mass in a given volume. If something has a high density, then it's heavy for its size. If something has a lower density, then it will be lighter for its size. Ice is lighter for a given volume than water, so solid ice floats on top of liquid water.
Fact number 5. Adding other chemicals to water can change the freezing point.
Water usually freezes at 0 degrees Celsius, but adding table salt to water makes the freezing point lower than 0. Table salt is also called sodium chloride, and it's the main salt found in ocean water. There are some places in the ocean where liquid seawater is colder than 0 degrees Celsius. Adding salt to water also increases the density, so lower density fresh water tends to float on top of higher density salt water.
Let's take a deep dive into the coldest places on Earth.
Water is essential for life on Earth, and if there was too much water frozen as solid ice, then living things could not survive. The planet Earth is just the right temperature for life because water is in all 3 states: solid, liquid, and gas. The coldest places on Earth have solid water as snow and ice. Oceans and rivers around the world have liquid water, and water vapor in the atmosphere is water in the form of a gas. The coldest place on Earth is Antarctica, where the temperature can get down to minus 90 degrees Celsius. There's a lot of ice in Antarctica, and it does snow there, but not very often. It's so cold in most parts of Antarctica that the snow never melts. It just keeps building up. The solid ice in the polar regions is very important for keeping the Earth in balance, but unfortunately, global warming is causing the Earth to warm up, and the polar ice is melting. As the Earth gets warmer, the polar regions are being affected. More sea ice is melting, which means there's less habitat for animals like polar bears and some types of penguins. With less sea ice, the ocean absorbs more light from the sun, which makes the oceans warm up even more. And when the oceans warm up, the volume of water in the sea increases, causing the sea levels to rise. Another cause of sea level rise is melting land ice. When sea ice melts, the sea level doesn't change much straight away because the ice was already floating in the sea. When land ice, like a glacier, melts, it causes the sea level to rise a lot more compared to the same amount of melting sea ice. You can test this out for yourself using 2 cups of water and some ice. Place 1 ice cube in the first cup and mark the water level before and after the ice melts. For the other cup, place the ice cube above the surface of the water. For example, place it in a tea strainer so the water drips down into the cup as the ice melts. Mark the water level in the cup before and after the ice melts. You should see that the water level in the first cup stays the same, but the water level in the second cup will go up.
Now it's time for a question. If there are some parts of the ocean where the water is colder than 0 degrees Celsius, why don't all the fish freeze?
The coldest oceans on Earth are around the North Pole and the South Pole. Even though the temperature of the salty seawater can be below 0 degrees Celsius, some types of fish can survive these chilly conditions. The fish have chemicals in their bodies to stop them from freezing solid. These chemicals are called antifreeze proteins, and the molecules can stick to ice crystals to slow down the formation of ice inside the fish. Warm-blooded animals that live in icy cold places have adaptations to help them survive too. Polar bears live in the North Pole and penguins live in the South Pole, so they never really meet each other, but they do have some things in common. They both have blubber, which is a thick layer of fat under their skin to keep them warm. The blubber insulates their body so they don't lose too much body heat to their surroundings. Another thing penguins and polar bears have in common is a water repellent coating. Polar bears have oily fur and penguins have oily feathers. Oil and water don't mix very well, so the oil keeps the icy ocean water away from the animal's skin. A different adaptation is used by a small frog that lives in freezing cold parts of Canada. The wood frog protects its body by making lots of sugar or glucose and storing the sugar in its cells. It also keeps a lot of urine in its body because it doesn't do a wee all winter, and the urine helps to protect the cells too. As the temperature becomes icy cold in winter, the wood frog's body freezes solid and its heart stops beating. If it didn't protect its cells with glucose and urine, the frog would freeze to death. But in spring, as the temperature increases, the wood frog thaws out and seems to magically come back to life. Its heart starts beating again, it starts to hop around, and it quickly finds a good place for a toilet break. Did you know that you can help to protect penguins by counting them for scientific research? A citizen science project called Penguin Watch asks people like you to volunteer to look at photos of Antarctica and count the penguins in each photo. This helps scientists to understand where penguin numbers might be falling so people can work to protect them.
Think about where you live. What's the temperature on the coldest day in winter? Think about your home. What's the coldest place in your house? In a lot of homes, the coldest place will be the freezer.
If you have a freezer in your home, the temperature inside the freezer will probably be about minus 20 degrees Celsius. It's quite a lot colder than the freezing point of water to make sure the food in the freezer stays frozen. Your fridge is probably about 4 degrees Celsius, which is cold enough to keep food fresh without freezing it. Food will go bad if it's left at room temperature because mold and bacteria can grow in the food, and these things can make the food smell and taste bad, and they can also make you really sick if you eat them. Storing food in the fridge will slow down the growth of mold and bacteria, but food will last a lot longer if it's kept frozen in a freezer. Before refrigerators were invented, people used other ways of keeping food cold to make it last longer, like storing food underground, or placing it in cold water in streams or rivers, or storing food in boxes packed with ice. The first refrigerators were made in the 1800s, but it wasn't until the 1920s that people started to have refrigerators in their homes. Most Australians didn't have a fridge until around the 1940s, and most of the early refrigerators ran on gas or kerosene and not electricity. Refrigerators and freezers keep things cold by removing heat energy. Have you ever touched the outside of your fridge? Did it feel warm? Moving heat energy from inside the fridge to the outside of the fridge takes a lot of work, which is why fridges use quite a lot of electricity to keep your food cold. When solid ice melts to form liquid water, it absorbs heat energy. Adding salt to ice lowers the melting point of the ice, and the ice tends to melt faster.
You can test this out yourself. Of course, you should tell an adult what you are doing and make sure you get their permission first. You'll need a freezer, a paper or plastic cup filled with water, small plate, rock salt or table salt, and some food colouring in a dropper bottle.
Start by filling the cup with water and put it in the freezer until the liquid water has frozen to solid ice. This can take a few hours, so it's good to leave it in the freezer overnight. Turn the cup of ice upside down onto the plate and squeeze the cup to release the ice. You might have to run some water over the cup to loosen the ice. With the block of ice sitting on the plate, sprinkle some rock salt or table salt on top of the ice. Add a few drops of food colouring to the salt. The colour will help you to see what happens as the ice melts. If the ice is melting too slowly, you can speed things up a bit by adding a few drops of water to the salt, on top of the drops of food colouring. Adding salt to the ice causes the ice to melt faster, and you might see holes or channels forming where the salty water speeds up the melting. In cities that have very cold winters, people sometimes spread salt over the roads to stop the snow and ice from building up on the roads. This de-icing has a few problems though. If the temperature drops too low, salt doesn't have much of an effect. Also, the salt can be bad for plants and waterways, and salt can cause cars to rust and fall apart. After all that icy cold science, it's time for us to go and warm up. Thanks for listening, and remember to stay curious.
The Creative Science Podcast was recorded on the traditional lands of the Bidjigal people. For more information about Creative Science Australia, visit creativescience.com.au.